Alright, in the last video we looked at introduction to logarithms, and this time we're going to look at properties of logarithms. And I first want to show you how these relate to properties of exponents. So I told you that logarithms are the inverses of exponents, and so they work kind of very similar. So if you remember, Math 2, we studied a lot properties of exponents, and the product property, product means multiply. When you multiply two exponents with the same base, you add the exponents. So multiply then changes to addition. Quotient means division. So when you're dividing exponents with the same base, that changes to subtraction. So same base of A, and then exponents m and n, and so we go from division to subtraction in properties of exponents. And with the power property of exponents is a power to a power, which means there's two exponents here, you multiply those together. So that one will be a little bit different with logarithms, but not too much. Alright, so properties of logarithms. So we're going to condense and expand logarithms using these properties. And even though this is only 3 of the exponent properties, and if you remember from Math 2, there were really 7 properties of exponents, but we're only going to look at 3 because we're going to have 3 basic properties of logarithms. So the product property up here, how we noticed that multiplication went to addition. Down here, you're going to see multiplication changes to addition when we expand that. Okay, so here we had a quotient, meaning division, and division went to subtraction. Again, we've got division of logarithms, and that changes to subtraction. And then a power to a power, the power is a little bit different. Here, a power to a power, we multiply powers. Here, we are going to multiply, but the power actually moves to the front. So it becomes not a power anymore. So the power actually goes to the front of the logarithm. All right, so make sure you have these down. These will be in your notes. I just wanted to go over the similarities between properties of exponents and properties of logarithms. All right, so we just looked at how a log base b of m times n is equal to log base b of m plus log base b of n. So this is the product property of logarithms, and we're going to use this property to condense to a single logarithm. So the reason we're doing this is so that later we can solve logarithm equations. So right now we're just going to condense and expand simple logarithms using the 3 properties that we've seen. All right, so using this property, if we go from addition to multiplication, we are condensing, which means we're going to have a single logarithm, okay? Which means we're only going to write log base 2 one time. And we can only condense these when they have the same base. So you'll notice that these both have base 2. These are both base 10. Remember, these are a common log because there's no base. We assume it to be a 10. These are base 4, and so on and so forth. So to condense, we're going to use the property. So we're going to say log base 2, and we're going to go from addition to multiplication. So we're going to have log base 2, that's the same thing, and we're going to have 7 times 4. So you can leave it as 7 times 4, or you can write it as 28. So we can write it either way would be acceptable, and you will see it both ways sometimes. All right, so all of these are going to work kind of the same way. So if you look, this one's going to be log of 25 times 4, or log of 100. And again, if you want to have a base, you can put base 10, but when there's no base, it's assumed to be base 10. All right, so log base 4, I've got 2x and 4x squared. So I'm just going to have 2x My addition changes to multiplication, and 4x squared. I can go ahead and combine my numbers and exponents using also properties of exponents. So log base 4, 2 times 4 is 8, and x to the first, that's the first power since there's no exponent, and x squared, so same base, add exponents, that's x to the third. Okay, so these may be written just a little bit differently for different people, but that's kind of how you do it. All right, so now we're going to expand. That means it gets bigger. All right, so up here we condensed, so we went from addition to multiplication, and here we're going to expand. So we're going from a single logarithm to a multiple logarithm. All right, so this has 6, so basically have to say, well, where did the 6 come from? Well, we could say it come from 2 times 3. All right, so the log of 2 times 3, we can go from multiplication back to addition. So log base 10 again, if there's no base, so log base 10 of 2 plus log of 3. And you won't use expanding as much as condensing, just because we use condensing to solve, but to use the properties, this is just kind of letting you know how the properties work. All right, so 45 is 5 times 9, so let's say log base 7 of 5 times 9, and we can rewrite that as log base 7 of 5 plus log base 7 of 9. So you see how we go from multiplication to addition. We now have log base 7 twice because we are expanding. All right, so here we've got log base 2 of 5 times x, or log base 2 of 5 plus log base 2 of x. All right, moving on to the second property, the quotient property. We're going to go from subtraction to division or division to subtraction. All right, so the first one says to condense. That means we're going to a single logarithm. So that means we're going to write log base 3 one time. So we're going to have log base 3, and subtraction changes to division. So I'm going to have 24 divided by 8. 24 divided by 8 can be reduced to 3. So I can also write this as log base 3 of 3. All right, the next one, single logarithm. So log base 2 of 15 divided by 15. That equals 1. So log base 2 of 1. And number 9, we're going to have log base 4. Subtraction goes to division. So x to the 9th over x squared. And properties of exponents, 9 minus 2, same base, you subtract exponents, so that reduces to log base 4 of x to the 7th power. All right, moving down to the next row. 4 can also be written as 8 divided by 2 produces 4. Anything that divides and gives you 4, you can write that. These answers are going to vary, but I can say what, and I'm dealing with a quotient, so what divides to give me 4? I'm kind of working backwards here. So I'm going to say 8 divided by 2. That's the most obvious in my mind anyways. Again, answers may vary. Anything that divides and gives you 4, that'll work. And then log base 8 of 8 on top first, and then log base 8 of 2. All right, so we're just using the property to expand. All right, so here I'm going to have log base 5, and I'm going to have a quotient of something that equals 1/3. Well, what equals 1/3? Well, let's see, 1/3, I can do 15 over 45. All right, so you may have chose 10 over 30 or some variation that came from 1/3. That's fine. Again, these answers may vary. We're just using the properties to expand. All right, so log base 5 of, I've got 15 on top, and I'm going to subtract log base 5 of 45. All right, and number 12. This one's base 10 because there's no base. We're just going to assume it's there. And I've got division going to subtraction. All right, the last property is the power property. So log base b of m to the n power equals n times log base b of m. So you can see that the power goes to the front and multiplies. All right, we're going to condense to a single logarithm again. So that means the number in the front becomes the power. So I'm going to say log base 4 of 2 to the 5th power. And then you can say log base 4 and 2 to the 5th power is 32. All right, here the 7 becomes the power. Log base 2 of x to the 7th. Because x is a variable, that's as far as you can go with that one. All right, this one has a 1/3 power. So this one's going to have log base 10. That's our common log to the 1/3 power. Now, if you remember when we did radicals or square roots, cube roots, etc., then you can also write this as a cube root. So this could also be written as log of cube root of 8. Okay, so these two are equivalent forms. Both of those would be acceptable. Okay, just using the properties, making sure you know and understand them. All right, 3 more examples here we're going to look at. And we're going to say expand. So for this one, we are going to expand. And we're going to use the power property. So now this time the power, the exponent, goes to the front and becomes the n. So we're going to have 7 log base 2 of 8. And again, these are all just the properties of exponents, the properties of logarithms. These are all just rules that you have to follow in math. Kind of like when you learn to drive and there's rules to be safe on the road. And these are just rules not to be safe, but these are rules so that we all get to the same answer. All right, number 17. All right, for number 17, it already has a number in the front, but to expand, that means we're going to bring our exponent to the front as well. So we've got x minus 1, and we already have that 3 out there, so we can say times 3, and then log base 10 again of 4. So if we want to, we can put this in parentheses because that 3 kind of would be distributed there. So it's going to be 3x minus 3 log base 4. All right, and a minute ago we said that the square root is the same as the 1/2 power, so we can rewrite this as log base 7 of w to the 1/2 power. And if we expand that, we would bring the exponent to the front, so 1/2 log base 7 of w. All right, so that's some examples of using the 3 properties of logarithms.